Hi, here I'm going to discuss about this prelim paper. I'm going to give you a sort of crash course on this. We'll try to solve this question paper within the given time limit. Of course, I'm not going to do question number 1, which is theoretical, but I'm going to do the numericals plus one derivation. So let's start with question number 2a. So it says that prove that latitude of observer is equal to the altitude of pole. Well, for a minute, suppose this is a rational horizon diagram. Here it is North Pole and South Pole. Here it is East and West. Suppose this is the pole here. And this is observer, zenith, Z, and Q, this is equinoctial. So we know it very well. If we measure P and Q, so it is PZ plus QZ. PZ plus QZ, this is 90 degree. So this one is 90 degree. Similarly, if we measure N and Z, this is also 90 degree. So this is nothing but NP plus PZ. So this side is also 90 degree. Now, we equate both the equation here. So PZ plus QZ is equal to NP plus PZ. Here PZ get cancelled. So I get QZ is equal to NP. Well, if this QZ, Q and Z, that is nothing but latitude of observer. And what is NP? NP is altitude of pole. And here this North Pole is the elevated pole. That is the pole which is above the horizon. Now let's move on to the next question. So in this problem, you are on 1st May. Okay, I think let me use this color. 1st May 2008 in position DR so and so. The setting sun. Remember, setting sun bore 290 degree compass. If variation was 2 degree west, find the deviation of the compass. So what we need to do is we have to open the almanac for 1st May 2008 and find the sunset time for the given latitude, which is 30 degree 6 minutes. Well, if we see here, this is latitude 30 degree north and it is 18 degree 38 minute. You don't have to be accurate for second. We can just pick up this timing. No issue. Now, this is the time and month is May. Then we use LIT, longitude in time, which is given 179 degree 30 minute. That's the longitude given. So 179 30 minute east. If you divide this by 15 degree, so I get 11 hour 58 minute and 00 second. And the rule is longitude east, GMT least, and GMT least, LMT will be more. So more will be when you subtract here. So after subtracting, I get this value. Now, let's have a look here. We need to find declination. Declination for 1 day and 6 hours. The date is 1st May. So let's find out. This is almanac 30 May 1st and 2nd. So we'll go to the 1st May and the timing is 18 hours. Let's find out, which is 15 degree 12.1. Now again we'll look at the almanac. Here D correction is there, which is 0.7, and if we see carefully, we'll see that it's 7.6, then 8.4. The declination is increasing, so this correction has to be positive. Now we look the increment, which is D is equal to 0.7. So we'll go to the increment table for 40 minutes and D is equal to 0.7. So the value is 0.5 here. Well, the total declination is 15 degree 12.6. Now all you have to do is just simply calculate this, which is cos rising setting azimuth is equal to sine declination upon cos latitude, and the value of latitude is already there. dr latitude 30 degree 6 minute, and declination we just obtained, which is 15 degree 12.6. So now with this formula I'm going to get this value, which is all right, 72.3. So I can name it as north and west. Why north? Because my declination is north. Let me come here. Declination is north. And why west? Because sun is setting. Well, then true bearing is 287.7. Now you should know how to compute. This is east, this is west, this is north and south, and sun is here. This is northwest. That means this angle is obtained 72.3. So all you have to do, you have to find this angle, which is 360 degrees subtracted. So I get 287.7. Now compass bearing is given, which is 290. So the difference is 2.3 degree west. That is the compass error. Now we'll go further. Compass error is nothing but variation and deviation. Variation is given 2 degree west. Let me just cross check again. Variation is 2 degree west. All right, 2 degree west. So 2 degree west plus deviation is 2.3 degree. So deviation is 2.3 minus 2, that is 0.3 degree west. That's the answer. All right, now let's move on to the next problem. Now this is question number 3. On 1st May 2008 in DR longitude 179 degree 30 minute east, the observed altitude of the sun's lower limb on the meridian was 64 and so on so south of the observer. If the height of I is given, find the latitude and line of position line. Now first thing first, we need to find approximate meridian passage time. So let's come here on the almanac on May 30 April, 1st May and 2nd. So here the meridian passage time is given on the bottom. So 1st May the meridian passage time is given 11:57. We'll pick up this value 11:57 0 second. Well, the date is 101 and month is May. That's the approximate meridian passage. Now longitude in time east is 179 degree 30 minute. You got to divide this by 15, you get hours. So 11 hour 58 minute and 0 second. Longitude east, GMT is least, LMT is more. Obviously we need to subtract. After subtracting, what we realize, this is 57, this is 58. Well, we need to take 1 hour from here. That is 60 minutes, so it becomes 59, and this 1 hour is less than we take 1 day from here. So it becomes 30th and 23:59:00. Well, the month will change from May, it will become April. So you got to be very careful. Now all you have to do is find the declination. Well, for 30th April and 23 hours, it is given here. 30th April, 23 hours, north 15 degree 6.9, and if you see D is small d correction is 0.7, and the value of declination is increasing here. All right. So 15 degree 6.9, the value of 0.7 as we have calculated earlier, it's 0.7 itself. So we get this 15 degree 7.6. Now what we have to do is find the Observed altitude is given. Observed altitude is 64 degree 35.9. Dip is height of eye. In the question, height of eye is 15 meter. So what I'm going to do is have a look. Height of eye 15 meter. This is the table A2. Let's come here. Height of eye 15 meter, which is 6.9. So here, okay, 6.8. Let me just check. 6.8. Yeah, 14.7 and 15.1. The height of eye is, the dip correction is minus 6.8. So apparent altitude is 64 degree 29.1. We just need to subtract. Then we need to apply total correction, which is for lower limb, because it says in. So this is for lower limb, and for lower limb the correction is additive, which is 15.5. Well, we can have a look in the table also. There are two tables. First is October to March, and another one is from April to September. We need to look in this April to September and just see what is the apparent altitude, which is 64 degree 29.1. So 64, which is between 61 and 67. So correction is plus 15.5. Now after applying correction, let's find out true altitude, which is 64 degree 44.6. We'll name it later. And meridional zenith distance is 25 degree 15.4, which is after subtracting true altitude from a 90 degree. Now look at this beautiful diagram, which is pretty simple but explains everything. Suppose this is Q, that is equator or equinoctial, which is 0 degree latitude, and declination is there. So this is X. So this is declination. So sun is here. All right. Let's say this declination is 15 degrees 7.6 minute north. So declination is north. Well, this side is north, up. Now the direction or the bearing. The sun is south of the observer. So sun is south of the observer. That means observer is in the north. So true altitude is south. So the meridional zenith distance is north. So sun here, suppose this is the observer here, Z. Let me just do the marking here. So suppose this is the observer here, and sun is south of the observer. So meridional distance is X to Z. This is north. So what is the distance of this observer from equinoctial? Well, you need to sum it up, both the values. So here the latitude is the sum of meridional zenith distance plus declination. So I get 40 degree 23 minute north. Now what will be the PL? Obviously the position line is going to be east and west in case of meridian passage. On 3rd May 2008, in DR position so and so. Yeah, in DR position so and so, the sextant altitude of pole star was 10 degree 30 minute, and LMT was so and so. Find the direction of PL and position through which it passes. So this is a pole star problem. Let's solve it. The LMT is given, which is 03, 3rd May, 18 hour, 30 minute, 40 second. LIT is given, which is 179.30, well, which is 11 hour, 58 minute. So I get GMT, 03 day, 06 hour, 32 minute, 40 second, and the month is May. Let me just write here. Now, okay. We need to find GHA Aries. So GHA Aries for 03 days 06 hours, we need to look at the almanac 311 30.8. Then we apply increment. I get this value GHA Aries 319 42.1. Now I apply longitude. So the formula is longitude east, GHA least, LHA more. So LHA more will be when I need to add. Now if I add, I get this 499, 12.1. Well, 499 is more than 360 degrees, so I subtract 360 degree here. So once I subtract 360 degree, I get 139, 12.1. Now we need to work on this table, sextant altitude. Okay, the sextant altitude is 10 degree 30 minute. Okay, let me choose this color. Then index error on the arc minus observed altitude, we apply dip and we obtain apparent altitude 10 degree 20.1. So the total correction we apply, which is 5.1. So we get true altitude. That's pretty simple. 10 degree 15 minute. Now we need to enter the Polaris table. And if we enter in the Polaris table, what we find, we take this value of LHA as 139 degree 12.1. In the same column, we find A0 as 1 degree 5.4, A1 is 0.3, and A2 is 1 minute. And azimuth is also given, which is 359.3. Well, it's pretty simple to refer the Polaris table and find these values. You may refer another video which explains the use of Polaris table. Otherwise, that should be pretty simple. So observed altitude is nothing but true altitude plus all these corrections minus 1 degree. So all we have to do, this is true altitude 10 degree 15 minute plus you add all these corrections. All right, minus 1 degree. So you get 10 degree 21.7. And well, it is going to be north only because this Polaris star is in the North Pole. Now, the position line, we have this azimuth 359.3 plus 90 degree. It gives me 1089.3 plus 180 degree. So 269.3 degree true. Okay, let's have this diagram. Suppose this was the DR latitude. The value of DR latitude is 10 degree 20 minute north. And observed latitude is 10 degree 21.7. That means towards north. So this is observed latitude. Well, this is the azimuth, which is 359.3 is less than a degree, but I have just little exaggerated the figure. The diagram is not to the scale. And then 90 degree to the azimuth is the PL. Well, let's start with this quickly. Let's run. On 30th April 2008, DR so-and-so sextant altitude of sun's upper limb east of Meridian was 44 degree 13.4. When the GPS clock showed this much, if the height of eye this, calculate the direction of position line. So we have this GPS time, which could be ambiguous. So 30th day, 13 hours 00 minute 52 second, or it can be 1 o'clock 01:00:52. Well, we'll figure it out. Now we apply longitude east, LIT west, which is 4 hours and 48 second. All you have to do, just divide this by 15. And longitude west, GMT best, LMT least. LMT least is in the situation where we subtract. So we subtracted and we find that LMT is local mean time is 9 o'clock morning time. And then if you see carefully, sun was east of Meridian. So that means this is the correct time. This is the morning time. Another one is 21 hours. That is the evening time. Sun was east of Meridian. So definitely we'll take this as a local mean time. So obviously this GPS time is the GMT time. So GMT time is given, which is 30th day, 13 hours 00 minute 52 second, and the month is April. Again, following the same procedure, what we have to do is just find GHA. Then you find increment, then you find GHA sun, which is 15 degree 55.7, then longitude west, which is 60 degree 12 minute. Again use the formula longitude west, GMT best or GHA best, LHA least. And how you obtain least LHA? This is 360 degree plus 15, and then you subtract this minus, so you get 315 degree 43.7. Now how to find P? The angle P is, if it is 0 to 180 degree, then you use P like this only. But if the LHA is between 180 to 360 degree, then angle P you can take 360 degree minus LHA. So from this we take angle P. Similarly, we find D and the increment, which is 0. So this is the declination. Now let's find out what is the formula for intercept. Well, for intercept, cos CZD is pretty simple, is equal to cos P plus cos L plus cos declination plus minus sin L and sin D. What is this plus and minus? L and D, if they are same name, it is positive, and if they are opposite name, it is negative. So here the values are given, L is given, declination is also given, and P is also given. All you have to do, put in the calc and compute, which will take 1 minute, and you get this value. CZD, calculated zenith distance, is equal to 46 degree 7.1 minute. Now let's work on true zenith distance. Well, sextant altitude is given 44 degree 13.4, index error is off the arc 3.1, so we add 44 degree 16.5. Now we apply dip correction, which is 20 meter, height of eye is 7.9. I've just taken the screenshot here. Then apparent altitude, which is 44 degree 8.6. Then total correction for upper limb 44 degree. Alright, and this is for upper limb 44 degree. So from where you have to find out 44 degree, so from 42 and 45, this is minus 16.8. so true altitude is this much. You subtract 90 degree, you get 46 degree 8.2 true zenith distance. Now let's summarize. This is the dr latitude, declination is there, P is also there. So A is equal to 10 latitude upon 10 P, which is 5.967 into 10 raised to the power minus 3. So you got to be very careful. It is 0.006, and the direction is always opposite to latitude, except our angle is between 90 and 270. So this direction is going to be south. Now similarly B is 10D upon sin P, and this value is 0.384, always same as declination. So once we have this A and B, so we can easily find C, because they are different name, so we need to subtract, and the value is always on the greater side. So north is greater. Now tan azimuth is 1 upon C into cos latitude, so I get azimuth 069.3 degree true. So the PL is going to be, I just need to add 159.3, that is 90 degree to this plus 180 degree to that, so 339.3. Now let's summarize everything. Calculated zenith distance, we found this. True zenith distance, we found this. So the difference is called intercept, and the rule is very simple. Now which one is large? True zenith distance. True is greater, intercept is away. Tom got away. Well, another way is, suppose this is dr latitude and this is dr longitude. This one is the azimuth we obtain. So from dr to the celestial body, that is sun, we find this distance, which is nothing but calculated zenith distance. Now actual zenith distance is more, so this is true zenith distance. The difference is intercept, which is 1.1 mile away or minute away, and obviously this is the PL. So from east to west, it is west and 300 degree. So I'll subtract from 360 degree, it becomes 60 degree east. So this angle is 60 degree east. What is the initial position? 5 degrees south. So this one is 0 degree here. This is 5 degree and this is 90 degree. So the value of PA is 95 degree. Similarly, this is the final position is 25 degree. That means from equator it is 25 degree. Well, if it is 25 degree here, so it means this is 90 minus 25, that is 65 degree. Now for distance, we have this formula cos AB is equal to cos PA cos PB. I think let me just correlate this formula here again. Yes, wait a minute. So cos AB, this side is equal to cosine of PA, this side, and cosine of this side, plus sine of this side and sine of this side into cosine of P. So all the values are given here. PA is given, PB is given, and angle P is also given. Angle P is nothing but d long. You put the value, get the answer 65.506. It is better to have up to 3 places. It can be more accurate, and round off 3930.4 nautical mile. That is the great circle distance. That is the great circle distance. Now we need to find initial course. We apply the same formula here from this side. So cosine of PB is equal to cosine of PA and cosine of AB. Okay, just let me explain this formula. All right, cosine of PB is equal to cosine of PA and cosine of AB plus sine PA sine AB into cos A. So we need to find cos A. Cos A is nothing but cosine of PB minus cosine of PA and cosine of AB divided by sine PA and sine PB. All you have to do, these values are given. PA is already there. PB is there, PA is there, and AB just now we have calculated. So what we have to do, just put these values here, and we find A is equal to 59.599 or 59 degree 35.9. Since our latitude was D-lat was north and D-long was east, so the direction is going to be northeast. That's it.